Okay, hello everybody. This is Nick Hatt. I'm a developer at Redox. What you're about to see is a talk I gave at the Redox Interoperability Summit last month. It got a really great response there, and it's a perspective that I don't really see out in the wild, so I wanted to share it in webinar form with you all today. The conclusion of this talk is pretty simple. I just want to prove to you that the problem with interoperability is not a technical one. To me, it's a cultural one and a business one. Ultimately, a lot of the things we can do with FHIR, we've been able to do for 30 plus years. It's not a silver bullet. I'm also going to offer a trigger warning. I call out certain people and EHR vendors in this talk. It's not meant to harm. If success in interoperability were about intelligence, we would have this problem solved already. Healthcare is an industry that does not need more smart people. I think we just need to reorganize how we do things. So breaking that down a little bit more, I'm going to get you to understand how we went from nothing to FHIR over the past 30 years or so. Give you a little bit of a FHIR 101, just enough to understand kind of some of the problems that still plague interoperability, and dive into some of those problems specifically and talk about the trade-offs that are preventing them from actually being fixed. So if you look on the internet for news about FHIR or information about FHIR, you're going to see a lot of irrational optimism. Some of these things are very clearly written by people who don't understand technology. My favorites on here are an internet-based approach. Well, yeah, of course. Hopefully you're using the internet to solve problems. And up there on the top, they say that Cerner was one of the first to understand what the F in FHIR stands for. I mean, just super cheesy and not really talking about the technical parts of it. A lot of people think FHIR is going to be this panacea, but really, it's an evolution. That evolution started sometime in the late 80s. So just as a thought exercise, think of your favorite API. It might be Redox, might be Twilio, Stripe, any number of Google, Twitter APIs. Now think of how you do that if you didn't have access to HTTP, XML, JSON, SSL, even widespread adoption of the internet. So you can't get data from point A to point B, even if both parties were willing. There's just not the cables there for it. This is exactly what the situation was when HL7 was born. It would probably be some kind of delimited format if you were doing it with a file. You might just tap in to the other party's database directly and get the data. Interestingly enough, some of our competitors do that right now still, tap into people's databases. If you see that, that's a mess. Just run away. But one of the things that I'm impressed by and kind of astonishes me is that people were trying to solve this integration problem even in those very early days. The systems were not very complex, but they still saw the value of sharing data between healthcare systems. So a group of people got together and they wanted to tackle some very simple problems. Number one, can we agree on a format and a model for these things? When I say format, I'm talking about how do we parse the data? Is it, how do those ones and zeros form a structure that we can read? Today we would use XML or JSON. Back then, not really anything to go off of. And then the model talks about how can we structure the data in such a way that it actually maps to the real world. So how does a patient relate to the allergies they have, and how do the allergies that patient has relate to the reactions to those allergies, for example. Second, we need to agree on how we're actually going to send this data across the wire. I call that the stack, and we'll see kind of the shape that takes in the evolutionary path here. And then number three, can we agree how these things integrate with actual events that happen in the real world? So if a patient gets admitted to a hospital, we might know the model for how the patient and their diagnosis link together, but how do we actually describe that admission event? So the first stab at it was something called HL7 version 2. Many of you have probably already heard of this. The sort of prior art at this point was a standard called X12 that's still used widely in healthcare claims. Basically, just delimited data. Still doing a lot of negotiation about what fields go where, but mostly something you can write down and describe. They also included a minimalistic method of transporting the data, so that stack. They really were constrained a lot by memory and processor speeds and network bandwidth at the time. So everything in HL7 version 2 is meant to save space, be very easy to read and parse, and yeah, in general, save space. They came up with a format, and there was also kind of this innovation of having multiple different domains. So they broke the problem down into patient administration, orders, scheduling, different sort of domains that you could iterate on and build sort of the tools you needed to solve each one of those problems individually. And then another key innovation was they sort of shared functionality across those functional areas. So a patient in scheduling will look like a patient in an order, which saves on implementation time. Here's a sample HL7 version 2 message. Just by scanning this, initially you might see some recognizable text. Right here I've called out where the patient's name is. So just by looking at the message, you can kind of see that it's text and there's interesting stuff in there. You don't necessarily know what is what unless you've read the spec. Up here at the top, you kind of have this metadata section, and they encode sort of each message as an event. This is an ADT A08 message, which is a visit level update. And if you know the spec, you know there's literally hundreds of events. But this one, all messages share this kind of similar structure where everything has a metadata section, and there's sort of that event that sort of tells you what the message is for. After that, everything's sort of broken up into these segments. Here I've highlighted the PID segment. Some people refer to it as PID usually. It stands for patient identifier, and this is that kind of composable component I talked about where you'll see this in all HL7 messages that deal with a patient. It's mostly the same between the messages. So HL7 version 2 overall was very successful. It got an enormous amount of traction precisely for the reason I mentioned earlier. There was just nothing there before. Created this whole new value chain, this whole new market. Today we have people who do this for a living, like build HL7 version 2 interfaces. There's a whole product class called an interface engine that you buy to mostly handle this kind of messaging. Implementation times were kind of still longer than you'd think. A lot of that comes from there not being very hard rules about where data goes. So I used to work at Epic, and in Epic you can have some crazy number of fields that might be the patient's visit ID. So it could be, like one of 7 fields. And then in the actual HL7, that can be in PID 18, PV 119, PV 150, all these different fields that are sort of like a visit identifier. And then those fields can repeat. So there's like just sort of a lot of negotiation that needs to happen so you're on the same page with the other system you're trying to connect to. Despite that back and forth, most people can live with it. There's sort of a de facto way of doing integration, and that's HL7 version 2. I'd estimate that about 95% of integrations in the world today are HL7 version 2. It's that widespread and that popular even 30 years on. So going back to these problems, I kind of gave HL7 version 2 a score. You might have a different score in your mind. That's fine. It's just they kind of nailed it when it comes to exchanging the data. Pretty much everyone uses MLOP to exchange this stuff. The standard format and model works pretty well. A lot of systems build in customization features sort of out of the box. So, in Epic, you can change where that visit identifier goes with the flip of a switch. But for the most part, you can sort of talk about that and have a conversation about it. And it doesn't have to be custom development each time. And then in terms of agreeing with how things integrate to the real world, there's, a lot of work went into that sort of modeling and event type development. So those are my scores. They, pretty good, almost all the way there. It really did what it was trying to accomplish, sort of giving us a standard on-ramp to build integrations. Of course, there were problems. HL7 saw that ambiguity as the biggest problem. Just trying to negotiate where to put something because the spec is ambiguous was something that you can solve with a better spec. And at the same time, new technologies were emerging. XML was all the rage. Computers were getting faster. We didn't need to limit ourselves to sort of these tiny compressed messages and doing things like MLOP. This is what an example I like to give of a problem called the second system effect. So Fred Brooks wrote a great book called The Mythical Man Month, and he describes something called the second system effect. Essentially, an engineer or an architect's second solution is going to be the most dangerous. They try to incorporate all the features that they missed in the first one. But really the reason they missed those features in the first one is because they were under like a time constraint, or they were starting from nothing and they really just wanted to try and get something out there. That's part of HL7 version 2's ambiguity, is just they didn't know everything that would be valuable. So they put extra stuff in. In version 3, they tried to solve every problem and add every possible feature, and it turned out kind of over-engineered. Here's an example. You'll kind of see that it's a lot more readable. There's a patient, name, family. You can sort of self-document with XML. But at the same time, there's weird things that aren't necessarily self-documenting. So here, there's a XML attribute called null flavor. I don't know what that inspires in your head when you hear that, but to me, it sounds like an ice cream flavor. What this actually means is that this field has no value, and actually null flavor can have one of up to 14 or so values. It could be no information, invalid information, so somebody typed something in but it didn't validate and it's just not there. It could be positive infinity, so if it's a numerical value, you can say the null flavor is positive infinity. It could be asked but unknown, so documenting that the patient was asked, in this case, what their ethnic group was, but they didn't know. Or it could be not asked at all. So really, they tried to build in all these complex features, and really, if you're imagine yourself building an EHR product and you have a field for ethnicity. Are you really going to put a second field there to put why it's not there? Like, yes, you asked, but they don't know. Really not practical use cases. There's also just weird stuff, down here I have a mood code, and I don't really know what a mood code is. Does that mean something about this language communication is happy or sad? It's kind of hard to wrap your head around the whole model of this HL7 version 3 spec. And a lot of people do it inconsistently. So one of the places that it's actually used is a standard called CDA. And this is really the only place you see v3 used today in the US, mostly because it was part of meaningful use. So what CDA is a way of representing a document. Imagine you have a stack of papers that you're taking from one doctor to the other when you have a transfer of care. That's kind of what it's trying to replicate, just a way to have a bunch of sections, so say your allergies, your medications, in a human readable and also machine readable way. But it's so ambiguous and hard to understand this HL7 version 3 model that for meaningful use, HL7, along with the consulting agencies and government money, made a 581-page document to supplement sort of HL7 version 3 to tell you how to do it right. When Redox first started, we were a very small company. We were at an incubator. I printed out all 581 pages and walked around with, it's a ream of paper to try and understand this spec. It's not it's not pretty. 3 years later, we're up to 917 pages, so this problem is not getting better. I should mention that my coworker at Redox, Benjamin, is one of the authors of this document, and it's not really their fault. It's just by trying to solve the ambiguity problem, they somehow managed to create more ambiguity. So, giving HL7 version 3 a score, they really nailed the model. I mean, it's really complete, but also impossible to understand, especially if you're, not devoting your full time to just understanding that model. You're a developer with different priorities and you want to get stuff done. It's totally not the right fit. They also didn't really think about the big picture. It was really just the model, and for that reason, there's no standard for how to exchange the data. It's sort of left ambiguous. So when we try to exchange those CDAs and stuff, someone else had to come in and sort of put a layer on top of it for exchanging. And then in terms of events mapping to the real world, they sort of just reused everything from HL7 version 2. So not a whole lot of innovation there. Same score. This was a problem, and other people realized it too. So Graham Grieve here, this is from his blog, August 15, 2011. He basically said, it's time for us to move on from V3. This is not working. This is not a technology that we're going to build the next generation of healthcare apps on. Him and others sort of started this project called FHIR in late 2011, and this is what it initially looked like. Again, kind of taking a new approach, but reusing parts of V3, reusing parts of V2 to sort of build this model of healthcare data. And this is from the Internet Wayback Machine. Here's what the FHIR website looks like today. This was a screenshot I took in probably October 2017. You can see there's a lot here. I'm going to try and break it down for you. And this kind of covers all the areas I was touching on the HL7, the problems they try to solve. So up there at level 1, you sort of have the foundation for FHIR. It includes things like how to build, an API that supports FHIR. So FHIR tells you how to build your API. They also have support for things like sending messages, like HL7 version 2. They have support for documents like CDA. They talk about how search should work, so you should be able to search things in FHIR and extensions. Level 2 is all about conformance. If you know who Roy Fielding is, like hypermedia is kind of embraced in FHIR. It's not all the way there, but basically you should be able to just hit one point, like one URL on a FHIR server, and be able to discover all the other things that the server is capable of. So here they they define a bunch of tools that you should be able to use to see, say, well, does your server have patients? Does your server have observations? Does your server support search in this way? So that you can really build kind of dynamic tools. Level 3 is sort of the who, what, when, where, why. These are more core resources. So patient, practitioner, organizations, locations. Each one of these things is called a resource in FHIR. So that's a term that comes from this REST world. But when you look at the actual resources, they have sort of these maturity levels and patient, location. These are really mature parts of FHIR that are sort of central to everything that FHIR represents. On level 4, ignore how financial there is comically large. Just an interesting CSS choice. But these 5 buckets, as of now, sort of are the everything else in FHIR. There's the clinical information, diagnostics, which is like lab tests and everything else, radiology reports, medications, all kinds of workflow type stuff. Scheduling is included in there. Financials is an area that FHIR wants to tackle as well. It's not very mature. But this is sort of everything else that revolves around and uses those patients and practitioners. And then at level 5, there's sort of things that you can even build on top of the other resources. And these would be things like clinical decision support, kind of things you would want to use if you were, say, building a model to, do AI on, do machine learning on FHIR resources. It's not very mature yet either, but just kind of things you'll see, like guidance response is sort of a clinical decision support thing, and measure is sort of a quality metric reporting framework. So thinking about things like that on top of FHIR. So digging down into a resource, I've opened up FHIR here, or FHIR patient here. And you can see it's really nice documentation. It's very clean. There are hyperlinks that can take you between the different properties and sort of the different types that make up this patient. Another nice thing is just sort of the relationships are very clean. So in HL7 version 2, for example, that visit identifier could have been in the patient segment. Here you won't get any of that. The visit identifier is something totally separate resource. The patient resource only has properties for things that really belong to that patient as an object. I really encourage everyone to go on the FHIR site. It's all freely available, which is a great innovation for HL7. And sort of check out these resources and understand how everything fits together. If you're building a system that needs to store healthcare data, FHIR is a pretty good starting point. It's a good model, and very sort of the HL7 process makes it so that it's well thought out. You might notice weird things though. So on patient here, you'll notice there's an animal property with a species and a breed and a gender status, but no race. So typically, if you walked into a doctor's office, they'd probably ask you to fill out your race on a form and not your species. Pretty much, we segment our healthcare in America based on humans, and animals go to the vet. But for whatever reason, FHIR they're sort of designed to be this universal thing. So, the laboratories who test human tissue can also test horse tissue, can also test dog tissue. So for whatever reason, patient also includes animals. So there's just quirks like that. But overall, there are innovations in FHIR. I don't mean to say it's not innovative, but just that the innovations are evolutionary. So most people are going to get a lot of benefit from this REST architecture, and that's sort of the way that EHR vendors have been implementing FHIR to date. Most of them are read-only at this point, but sort of the uniform interface there, where you can take a search that you're using with one EHR vendor, use it on another EHR vendor, and it's all a GET request, and the URL is sort of the same. That's pretty valuable for implementers to be able to have that. The second kind of innovation with FHIR is that it's evolving at a different pace for different resources. So HL7 is a process-oriented organization. All of this stuff is voted on. It's designed by committee. But it's not really slowing down FHIR. So you'll see patient is very mature, but maybe say like financial claim is not. And that's by design. So they're not trying to release all of FHIR at once. They're trying to focus on core elements and bring everything up as they're ready. They're also willing to bring in other standards that have been successful in other industries. And so SMART, some of you may have heard of SMART on FHIR. That's one area where they've taken sort of best practices that Facebook or Google would use for authentication and authorization, and sort of mapping it onto FHIR and figuring out how you would build an app that connects with a FHIR backend. But again, these are all sort of sustaining innovations on top of what HL7 already did. There's not going to be a new type of job created because FHIR is any different than HL7 version 2, right? The same interface engineers who do HL7 version 2 will need to do the same things for FHIR. And so to sort of illustrate that, I'm going to go through some stuff that I pulled off of open.epic. And I pick on Epic because I used to work there. They're also the best at FHIR, I think. Their website is very nice and well documented, and I think they've made the most progress on sort of implementing some of these FHIR specs. And I also know most of the people who work on FHIR, so I don't feel too bad about throwing them under the bus. But here we have a device resource from open.epic. That's sort of their sandbox. Device is a resource that represents any kind of device that a patient may use. And here I have a pacemaker for a patient named Jason Argonaut. On the right-hand side, I've pulled up the FHIR spec. And so I just compared them. First thing you might notice is there's some fields that are a little bit different. So in the Epic version, there's a field called expiry. I'm not sure if that's a word or not. And then in the FHIR spec, it's called expiration date. So what happened? What we're looking at is a difference between FHIR versions. Epic is on FHIR version 2 or release 2, and the specs I'm looking at are on release 3. And the difference between the two of those was about roughly a year and a half. So October 2015 for the Epic version, and April 2017 for version 3. So this is a problem, right? This is something that goes back to that negotiation phase where you're looking at a resource as an interface analyst, and you see that these fields are different. You somehow need to map, expiry to expiration date if Epic hasn't upgraded their specs for you. You might also be looking down here, and you see that this is for a pacemaker. And there's this weird long number here. So you can see the display says pacemaker, and there's a code for 110. But what is this long number? If you've never seen one of these before, it's called an OID or OID, and it stands for Object Identifier. So you can actually go online to HL7 and look up what this is. You won't get very far down that chain. So each dot is supposed to be a new sort of namespace for it. You'll stop right here and you see Epic assigns OIDs under this node for each customer production deployment. So that's not great. That means that every Epic customer you go to is going to have a different OID to represent this kind of device. It's not what FHIR wants. FHIR says to use this value set, and this is all part of that conformance stuff that FHIR provides. And they say that this value set contains codes from SNOMED, where the concept is a device. And if you look at that, well, here's the code for pacemaker. So another example for Epic. This is probably against the terms of service of open.epic, but I felt like it was important to show. I actually took this off the site. But this is just a really simple field like the visit type. So when you go to see your doctor, what kind of visit is it? Epic's basically saying, FHIR recommends these types of codes, but that doesn't work for us. So it's not good enough. And I agree with them. It's really hard to do things, make everybody use the same codes for everything, especially if you're trying to be innovative or you're trying to sort of give your patients the best experience possible. Let's say, you start doing different kinds of telemedicine visits, and you want to bill differently for those. You want to report differently off of those. You want to build new visit types for them, and the process should not be to go back and try to update the code set. That could take years. You just want to make that new visit type and run with it. But then you need someone on either end to go back and map that new visit type back to something that's in the code set or something. It's still very hard to pin these things down. And I think we're starting to sort of get at why this is hard and why we still need to do a lot of work with FHIR integrations. It's not plug and play. Each production deployment is going to have different codes for different things. It might not be necessarily for devices, but for visit types, sure. Health System A has 100 visit types. Health System B has 3. That's the reality of the world we live in. And then fixing these things is not trivial. It's very long projects that involve a lot of testing. Imagine going to assign codes for all the devices that you implant into patients or that you send home with patients. You want to do really extensive testing. You want to make sure that you're using the right codes in the right places. And this is ultimately a human potentially doing these mappings. There's no guarantee that you're going to get it right. So you want 2 people full time. Could take them months. There's just a huge trade-off with trying to do these things. It's the same problem with labs and LOINC codes. A lot of people went through this for meaningful use stage 2. That was part of the government's requirement. It's just massive, massive project. And really the trade-off is just between having someone do it on the interface, mapping these things, versus like going into the core and changing all these things where you could break way more stuff. So you see why most health systems will opt not to do this. I'll pause for a few laughs there. So Redox, if you don't know what we do, we sort of do this as a service. We figure out what's different between all these different health systems, and we plug them into our network where we can standardize things. And you'll see that one side of these tables here are sort of all the same, and the other side, it's anybody's guess. Could be numbers 1 through 9. It could be numbers 0, 1 through 1, or just kind of random numbers. So 2 through 12, 3 through 12 are missing, or it could just be 2-letter codes. This is sort of an HL7 version 2 problem that we're solving, but it's very likely going to be a FHIR problem as well. While we're on the topic of race, you might be wondering from earlier, how do I represent race in FHIR? So there's this concept in FHIR called an extension, and basically any resource can just have this extension property on it. where you stick in an array of a bunch of extra fields. As a developer, I have a huge problem with just the way this is structured. It's like I think it's an anti-pattern. But culturally and business case E, I'm really afraid there's going to be a lot of confusion and lack of standardization around these extensions. So the first real use case for extensions we've seen is from Project Argonaut. Basically a bunch of EHR vendors who are sort of running on a different track than FHIR and sort of making FHIR useful for America, because we love putting rates on every single form. And they've defined these extensions. They have a specific code set that they should follow. But really, this is something that we could see change in the future. The government changed a lot of rules from meaningful use 1 to meaningful use 2. There's nothing that says they can't change. They can't say this year, you use these extensions for the patient resource, versus like 2 years from now saying, okay, you must use this new extension now. It's really unfortunate that a lot of the key information that we need has to be in these extension properties. And I might be asking myself, if I'm an EHR developer, is FHIR really making my life that much easier? From the Redox perspective, it's making our lives easier because we don't have to deal with HL7 version 2 and sort of the crazy things that people come up with for that. But we're still seeing the same kind of routine weirdness where you're dealing with different codes. But I'm going to touch on this a little bit later. But you kind of put yourself in the shoes of an EHR developer, and you have this database, and you're trying to build the easiest way for people to access this. Is it really going to be FHIR, or is it going to be sort of an API that you come up with? And part of that is sort of understanding how you're plugged into the whole ecosystem. I have to credit my colleague James Lloyd for this subtitle here. But if I'm an EHR vendor and I want to provide the most functionality through an API, this is sort of the process that I'm following with FHIR. I'm waiting for FHIR to be updated, for one. So there are sort of these rolling interim releases, so I can see what's coming down the pipe, but I don't necessarily feel confident making the change until it's published. It's officially voted on that something's changing. So I kind of wait until it's updated. Then I maybe give it to somebody on my team. They sort of have to understand the change, understand why the change was made, update my code, update my FHIR servers, everything I would have, follow that EHR release cycle, and ultimately get it out to the customer. That could take 6 months. That could take a year. It really depends on the EHR vendor and how they release stuff. But then I'm also then worried about sort of the government and the mandates that will come down to do things in a specific way. So they might take an extra year and sort of come out with a rule. I have to go back to the drawing board, sort of make sure I implement it exactly as it's written in the rule, and then attest to it and get certified. So it's problematic. By the time the health system actually gets their hands on that update or that patch or whatever, the process isn't done. They still have to install it. They still have to turn it on. Hopefully the EHR has made it in such a backwards compatible way that I'm not breaking all the people that were using the old resource before. For example, that expiry to expiration date. If someone's built their app looking at expiry, are you going to go talk to all the 3 or 4 or 50 applications that are reading device data from you? Probably not. You'll want them to upgrade gracefully on their own path. So there's a long transition period there. So it really, if I'm a developer, I really probably am annoyed by FHIR and how long it takes and how sort of how many people have their hands in the cookie jar. Making your own API like we do at Redox is actually kind of nice, because you can sort of move as quickly as you want or as slow as you want, and build those build those features in that people actually need versus, trying to conform to someone else's ideas. So we're getting to the conclusion here. Ultimately, I think a few things need to change. For one thing, there's a lot of lawyers that write healthcare technology recommendations. That's not really helpful for developers. We need to be more developer focused and provide good tools. FHIR is making a lot of progress in that area, but again, it's we kind of live in this post meaningful use world, and it's hard to imagine the government taking a step back and saying, okay, we don't need to make all these rules. They're already sort of there. So that's a challenge, and I think it's a cultural challenge. And I don't think that CMS and the government are really going to embrace the developer community the same way that, like, say, FHIR or Redox does. Culturally, EHRs, they're not trying to data block. I don't think that this is not a conspiracy to prevent people from sharing data. It's really more that they have different priorities. They have different values. Their first duties to their customer, and if their customers don't need FHIR, they're not going to build that much FHIR into their product. Other EHRs that are sort of cloud-based and don't do any FHIR, their APIs are great. They are building those for use cases and to spur innovation. So, something needs to change there. EHRs could see themselves sort of being these innovation hubs, but at the same time, I think they're trying to hold on to their existing business model more than they should. Health systems, they have like the most trade-offs to make. They're under a lot of financial pressure, and doing a project like putting SNOMED codes on all those devices, that just doesn't make financial sense. So the culture of interoperability needs to come from somewhere. Kind of the idea with Redox is that we can sort of take a lot of the burden of connecting systems off of the health system. So you connect it to one central place, and that can go out to anywhere else on the network, versus sitting at the health system and looking outwards and saying, oh my God, there's a million different places we have to connect to. Just giving those people one place to connect to and sort of a consistent way to integrate. In terms of business models that need to change, I think HL7, the FHIR development happens because it's funded. If it wasn't being supported by EHR vendors and consulting firms and governments, it would just sort of be a hobby still and not very robust. The FHIR, HL7 and FHIR, they need to watch out for these API marketplaces. I think, like I said, that EHR developers can move a lot faster and make a lot more impactful APIs if they're not using FHIR. So the value needs to be demonstrated. If you look at other industries, like let's say social media companies, Facebook's API is totally different than Twitter's API. It's totally different than, say, Google Plus's API, and for good reason. That's sort of their prerogative. I can see us moving towards a world where EHRs just have proprietary APIs and you connect to them one-off. Again, that's a problem we're trying to solve with Redox by giving you one API that already handles the difference between, say, Athena and Epic doing HL7 version 2, or Epic doing FHIR, or Cerner doing FHIR. the biggest thing is just the connectivity. So we don't really care how you share the data. We just want to get our trust with you built. So we're gonna, if you can give us a problem list in FHIR, that's great. If not, we'll get it from a CDA. If not, we'll get it from an API. If not, we'll get it from HL7 version 2 and provide the same interface to anybody who wants it on the other end. That might be FHIR on that end. That might be the Redox API. It's really up to the consumer. So we're back to the conclusion. I hope you enjoyed this talk. We have some time for questions. Again, to sum up, you'll see this this hype for FHIR, and it's really warranted in some ways. There's some great things that it's bringing to the table, but it's really not changing the fundamental structure of how we share data. It's a sustaining innovation on top of 30 years of work, and we really need to fix a lot of other things before we can truly get this beautiful network of shared data across the country. So I'll take any questions we have in the next few minutes.